All right, thanks, Eric. So yeah, hi, and welcome everybody to our annual merit review this year. I miss everyone's smiling faces and wish we were there together in person, but hopefully next year. So again, my name is Jesse Adams. For those that don't know me, I've been with the DOE Hydrogen and Fuel Cell Technologies Office for over 16 years now, working primarily in hydrogen storage, but also delivery and infrastructure, manufacturing fuel cells, kind of all over the board. So I recently took over as the Technology Acceleration Program Manager about 6 months ago. So very excited about the new role and happy to be on a part of Sonita's management team. Also want to make a few acknowledgments before I get started. So my first is Fred Joseph, my predecessor, big shoes to fill there. And then also want to acknowledge a couple of longtime team members, the first being Nancy Garland, who retired after 34 years of federal service, so congratulations to Nancy, and also Jason Marcinkowski, who recently moved over to the DOE Nuclear Energy Office. Of course, we're still working closely with Jason and the NE office, so he's certainly not gone, but congrats to Jason on his new role. So I wanted to start off here just with a snapshot of the Technology Acceleration Subprogram, give you a little insight into my vision for the team. I do want to point out one thing just to avoid confusion. The Technology Acceleration Program is also referred to as the Systems Development and Integration Team within the congressional language. So now that we have that out of the way, if you kind of look here at the, let's see if I can change my pointer options to laser pen. So up in the upper left here, you guys already heard from Ned and Demetrius talking about all the great work that's been done on the hydrogen technology side and within fuel cells. And so the idea here is to work closely with those guys, integrate with them, figuring out, all right, what are the technologies that are really making progress? What are those technologies that we need to demonstrate and validate? Going down here under systems analysis, so you'll hear from Neha Rostagi and her team next. So working closely with Neha to figure out, based on analysis, based on total cost of ownership type things, what are those sorts of end uses that we should be looking at? And then if you come all the way over to the right side, these are all the different end uses. I will get into a lot more of these in detail here in a minute, but you can see technology acceleration is right at the epicenter of all of these kind of different areas. So if you look along the kind of the yellow bar here, our goal is to identify these new market opportunities and then validate the technology, integrate these different systems together, and then assess their commercial readiness. And of course, we're going to do that all through the new big push with the administration is, demonstrating these hydrogen systems, and of course, the all-important feedback loop to guide the R&D and analysis. Now, part of all of this is underlying all of it is the enabling technologies. So this includes manufacturing, also some of the supply chain development. We have safety codes and standards, and then we also have workforce development. So these are all the enabling technologies that must be integrated and interwoven with the entire value stream here. All right, so moving on to my next slide here, just kind of another snapshot of the program and a little bit of a evolution of how we've come to be where we are. If you go back roughly to 5 years, 2017, you look, that's kind of when Technology Acceleration R&D team was formed. At that point, it was kind of a whole bunch of different teams that were all merged together. So tech validation, market transformation, manufacturing, et cetera. All these teams were kind of merged together, but fairly stovepiped, not well integrated together. And so then that leads me to my vision today, which is really now looking at our current focus areas. So now it's a fully integrated team, everybody working together on a common set of kind of end uses. So the first one here being the integrated clean energy system. So that's things like energy storage, hybrid approaches to enable high penetration of renewable power and provide additional revenue streams for nuclear. The next one down here, chemical and industrial processes. That's for those hard to decarbonize sectors such as steel, ammonia, cement, those areas where electrons alone likely won't offer the ideal green solution. And of course, we still are heavily working on transportation along with fueling. Right now, mostly focused in on medium and heavy duty trucks, rail, marine, and others. And then, as I mentioned earlier, we still have this enabling activities, which includes manufacturing safety codes and standards and workforce development. So you take all of that together, this nice integrated approach with a common end goal, and that's demonstrations of hydrogen and fuel cell technology end uses that accelerate technology, reduce greenhouse gas emissions, and ultimately enable this H2 at scale vision that we all know well. So with all of that, I still do want to specifically highlight that hydrogen safety remains an overarching priority for the program. This group, led in the office by Laura Hill, plays a critical role to enable the safe deployment of hydrogen and fuel cell technologies. So on the left side, the codes and standards. Our goal here is to support and facilitate the development of essential codes and standards. Of course, to do this, you need the RD&D is required to provide the scientific basis behind those various codes and standards. And then over here on the right side, safety side, our goal here is to identify and develop best safety practices and then share that information as broadly as possible through places such as our h2tools.org website. Looking at our budget, it has remained relatively stable here for the last couple of years, about 51 million. You can see that 51 million is over all of the different key technologies that I talked about before, the enabling activities, safety codes and standards, manufacturing, transportation, integrated clean energy systems. The one notable missing piece here is the industrial and chemical processes. I have a footnote here that actually we just started 2 new high steel projects. I will talk about those in a minute, but there was $8 million funded for that work under a different pool of money within the program. So we actually do have all of our different focus areas covered in managing projects within TA. Finally, looking at program direction, we're hoping in the future here maybe to look at some more of these different end uses, such as decarbonizing ammonia, maybe looking at some offshore wind to hydrogen, and continue to focus in on key aspects of decarbonizing steel, integration with nuclear and renewable, Super Truck 3, Demetrius mentioned this a little bit, and I will go into more details there, and then of course our enabling activities. All right, so I'm going to switch gears here just a little bit now. I'm going to hit on a few of the highlights across the Technology Acceleration Program, some of the different projects that we're managing. I'm going to start with the integrated clean energy systems portion of the portfolio, and that's roughly included within this H2 at scale diagram, roughly in this blue circle here. So the first 2 projects, both of these are large demonstration projects that started roughly 18 months ago. They really do a great job of emulating the H2 at scale vision at a local level and show how the H2 at scale vision can be realized in different regions with different hydrogen sources and different end uses. Both projects show how hydrogen can help facilitate renewable energy market penetration, and actually they both go a little bit further than that. Both of them include a vehicle application as well. There's a fueling station there and fuel cell electric vehicles here. The Frontier Energy project, this project is housed in Texas. It's demonstrating co-located 100% renewable energy generation to supply roughly like 100 kilograms per day. They're getting that hydrogen both from renewable energy as well as landfill gas. And then they're going to use that hydrogen to power a 100 kilowatt fuel cell powered data center at the University of Texas and supply a fuel cell vehicle station or fueling station. Project over here on the right is led by Plug Power. So this project is in Florida, and it's focused on the economic dispatch models for grid utility control. And so this project's planning to implement a 500 kilowatt electrolyzer. It also includes storage and a fuel cell facility, or a fuel cell at the Orlando Utility Commission site. So here they're really focused in on mitigating fluctuations to a large PV farm that they're connected to, and also providing backup power, and again, supplying hydrogen for this fleet of utility trucks. Thus far, these projects have really been doing a great job, making good progress. The initial site plans are essentially complete. The initial load data has been collected, and the various end uses have been confirmed, and agreements are being signed. All right, moving to our next two projects I want to discuss. Both these projects are focused in on integrating hydrogen production through electrolyzers with baseload nuclear energy power. So you may have heard some of this from the colleagues or our colleagues over in the Nuclear Energy Office already. But the idea here is that since nuclear power plants can't easily ramp up or ramp down to match the dynamic grid pricing, oftentimes the nuclear plants are just running at a loss. So to avoid that and avoid running at a loss, we want to produce hydrogen that can then offer these nuclear plants an additional revenue stream. So the Exelon project here to the left, their plan is to install a 1.2 megawatt PEM electrolyzer. It's going to be a NEL electrolyzer at an actual nuclear power plant. And Sunita briefly touched on this during her presentation, but the site has just recently been announced by Exelon. It's going to be at the 9 Mile Point site here in New York. So there's a nice picture of it here. And so they're going to use the hydrogen produced here to provide in-house needed hydrogen that they're going to use for cooling. One other notable outcome here from this project is NREL has completed the acceptance testing of the NEL electrolyzer over 500 hours now with very little degradation. On the right side, this is a project that we just recently selected, so it's actually still under negotiation with Fuel Cell Energy. And so they are going to integrate a 250 kilowatt high temperature solid oxide electrolyzer with a nuclear plant emulator that's going to be built at Idaho National Laboratory. Hopefully with both of these projects can show the potential of marrying nuclear and hydrogen energy and provide the nuclear industry increased operating flexibility and profitability by switching between power and hydrogen generation. All right, so you know, the integration of the electrolyzer with the nuclear side is wonderful, and but with that, we obviously still need to reduce the cost. We still need to improve the durability and validate the performance, especially for our solid oxide electrolyzers, which may be a little bit further behind their PEM counterparts. So as a result, we have a project here that spans both Idaho National Laboratory as well as Pacific Northwest National Laboratory. So this project aims to partner with industry, validate the performance of the electrolyzer stacks from industry, and then also work with them to solve things like cost and degradation issues. And they're going to do that through, you know, MEA development, modeling, post-mortem analysis, and various novel manufacturing techniques. So pretty cool stuff here on the INL side. They've now partnered with 5 different industry companies that produce these solid oxide electrolyzers, including Bloom, Nexeris, Oxeon, Fuel Cell Energy, and Holder Topsoe. Of those, they've now tested stacks from 2 different companies. 3 more are lined up and should be tested later this year. The notable achievement here is one of the stacks achieved over 4,000 hours, 25 kilowatt stack, less than 0.5% degradation per 1,000 hours. So pretty noble achievement there. That stack was tested at different temperatures, different power loads, and really went through its paces and performed admirably. Over here on the, well, I should say first, there's a 50 kilowatt test stand. This is the nuclear power plant emulator that I had mentioned. This is what the Fuel Cell Energy stack will be tested on. Over here on the right at PNL, this is, I believe, a 1 kilowatt stack. The notable achievement here is they were able to produce 300 centimeter squared large area cells. All right, next 2 projects, again, 2 more examples of integrated clean energy systems. On the left side is a schematic of the Advanced Research and Integrated Energy Systems, or ARES, as it's better known by. That is being launched by NREL right now, and Hydrogen and Fuel Cell Technologies Office is working closely with NREL, and happy to show that ARES will include several hydrogen production related pieces of equipment. And so that includes a 1.25 megawatt PEM electrolyzer, 600 kilograms of hydrogen storage, as well as a 1 megawatt fuel cell. So most of all this equipment has now been procured, or it's being shipped in, and so hopefully all of this will be up and running and integrated later this year. A couple of other notable things, they are a lot of work here on the controllable grid interface. So it's, ARES just isn't about hydrogen and fuel cells. It's really about the complete integrated package. At the Flatirons facility with NREL, they have wind, they have solar. These controllable grid interfaces, a 7 megawatt version, a 20 megawatt version. So all of this can be integrated together, and it really provides a nice test platform for industry to be able to come in, showcase their technology, maybe validate an electrolyzer, maybe show how you could produce hydrogen from wind. I'll really look at a complete test bed type setup. Over on the right, this is a brand new project with Caterpillar, and so I believe this project will demonstrate the world's first large-scale hydrogen fuel cell at a data center. The project plans to install a 1.5 megawatt Ballard fuel cell at a Microsoft center in Washington State. So in this case, the fuel cell is going to replace diesel generators and offer roughly 48 hours of backup power on site. So I think the big thing here is just to note that hopefully this demonstration project will provide the increased confidence and comforts in hydrogen and fuel cells in the IT world. So these data centers require like 99.99% uptime. And so I think the Microsofts of the world are very interested in hydrogen, but they're also kind of unfamiliar with the technology. So hopefully this is the initial step for them to gain that comfort with the technology, and hopefully we can start implementing this into other data centers. All right, so now I'm going to shift gears a little bit again and kind of focus in on some of the stuff we're doing in the transportation space. I'm going to start with a couple of projects in the medium duty space. You've heard about both of these projects already today. The one on the left, this is a project with CTE to demonstrate a fuel cell hybrid electric delivery van. And so in this case, they're partnering with UPS, and a total of 15 trucks are planned to be built, these box trucks. 5 are kind of already built and being tested, running around California. 10 more in various states of assembly, and everything should be completed and up and running later this summer. And as Sunit already mentioned, this is a pretty interesting thing here that UPS is planning to operate these trucks in a disadvantaged community in Ontario, California. So really this helps support the president's goal of making environmental justice a priority. On the right side, you heard quite a bit about this from Demetrius. So NREL has collected real-world data from fuel cell buses. It's tracking a total of 38 buses, and as already mentioned, 12 of those have already surpassed 25,000 hours. One surpassed 32,000 hours. So obviously we need to drive down the cost, but it shows that the sorts of durability that we need from these fuel cell systems for heavy-duty applications is achievable. The other notable achievement here is that they have seen an average of approximately 2x greater fuel economy compared to CNG or diesel equivalent buses. Finally, the bottom of this slide, I'm excited to note that for the first time, hydrogen fuel cells will be part of the SuperTruck program. So back in April, we released a $100 million funding opportunity announcement for SuperTruck 3. The FOA is currently in process. But I can say that the interest on the hydrogen and fuel cell side has been tremendous. Those new awards, all of this is, I guess, managed jointly by Hydrogen Fuel Cell Office and our sister office, the Vehicle Technologies Office. And these awards will be announced this fall, and really excited to get some truck demonstrations out there and on the road. All right, so our next slide is focused in on the maritime space. And so on the left, we're just kicking off a new project with Hornblower to demonstrate a first-of-a-kind maritime hydrogen refueler, which will operate on a barge on the San Francisco waterfront. The barge will provide roughly 500 kilograms of hydrogen per day and used to fuel a variety of things. So you can see here a schematic. This is the barge, and so it will have the electrolyzer to produce the hydrogen. You could use that hydrogen to power to fill a truck. You could use it to power a fuel cell, to charge batteries for maritime applications. And you can also use it here. There's a picture of a ferry. So this ferry is currently being built. I think it's actually very close now, made by Switch, and it's going to be called Sea Change. And this is a 75-passenger ferry catamaran that will be operating in San Francisco and using the hydrogen that will be produced on this barge by this new Hornblower project. So pretty cool, sort of first of its kind demonstration. Moving to the right side here, Argonne National Laboratory has done a total cost of ownership analysis for us for passenger ferries. On the y-axis here, this is dollars per passenger, and you can see this is the baseline comparing against diesel. Right now, the cost is too high, but if we start meeting some of our targets, we can see how we can actually meet cost parity with diesel into the future. The sort of tan colors here represent the fuel costs. So that's the big key, is we need to get the hydrogen cost down, which of course matches well with the H2 scale vision. We also need to meet some of the fuel cell cost targets of $60 per kilowatt hour, or per kilowatt, sorry, that Demetrius mentioned earlier. Sticking with this theme, we've been looking at rail as well. So Argonne National Laboratory has also done a total cost of ownership looking at passenger rail. So on the left side, so this is on a cost per mile basis, but looking at diesel multiple units, again, we're a little higher, but we can again see a path towards meeting cost parity with diesel. Again, the fuel cost and the fuel cell cost are the keys there. With both these total costs of ownership analysis from Argonne, it's preliminary. We're still gathering feedback on those. But the next step would then be to back out specific targets in both of these application spaces. So look for those coming out hopefully soon. The other thing I want to mention too, we don't have any specific R&D right now in rail. There is a light duty passenger rail going in San Bernardino County. That's not funded by our office, but that's interesting to note. And also the California Energy Commission is funding this hydrogen switcher locomotive. And so DOE, actually Pete Devlin will be sitting on as a technical advisor for this particular project, and actually pretty cool project because it's kind of like a rail yard dog. It's going to be bouncing around, seeing tons of G-forces, tons of vibrations. So we will see very quickly how fuel cell systems kind of hold up in this very tough environment. All right, so the next project here I want to talk about, we've talked a lot about all the different applications for fuel cells for heavy duty applications, but the fueling infrastructure is just as important. Obviously, you're going to need the hydrogen to power all of these heavy duty applications. And, these applications are also going to take a lot more fuel. So just kind of for reference, our long haul heavy duty truck fueling target, you need 10 kilograms per minute. That's close to an order of magnitude. I should say that's average, and that's close to an order of magnitude higher than you need for light duty passenger cars. So with that, we are going to need some R&D and some development in this area. On the left is a project we have with electroCore. It's been running for about a year now, and they've partnered with Way and Bennett to develop a dispenser and a nozzle, and that nozzle includes the receptacle, the hose, the breakaway, the whole deal. And the goal here is to meet $10 per kilogram to meet that target we have for heavy duty trucks. So they've been working really closely with industry and making really good progress. They have an initial design, and thus far, that design, they've run CFD modeling and FMEA analysis, and everything looks pretty good. Also, a quick mention of an electroCore project. This one's a little bit older. It's been going on for a few years now, but happy to note that this mobile refueler has now been built and tested. It's capable of fueling 20 to 40 vehicles per day, and hopefully very shortly it'll be open to the public for fueling. And also some talk here that we could use this potentially to look at fueling some medium duty vehicles as well. All right, so my last slide in the transportation sector, on the left side, so these are again different new end uses. This is H to the rescue. Sunita covered this in detail, so I'm not going to talk a lot about it. Just to say that this is a great collaboration, kind of government-wide. So hopefully that vehicle will be kind of up and running kind of next year. And then on the right side, so we have a long history in the office now of doing various workshops in the transportation space. Going back to 2018, we did heavy-duty fuel cell truck workshop, and followed by rail, ports and maritime, aviation, airports. So now, in the latest string of that, wanted to announce save the date, September 22nd through 24th, for a hydrogen heavy-duty off-road equipment workshop that Pete is going to be heading up. So when I say heavy-duty off-road, in this case, I mean excavation equipment, mining equipment, and agriculture, which also has a nice tie-in with the president's push on the agriculture side. All right, so switching again to our industrial and chemical sector. So we have two brand new projects here just kicking off related to iron and steel making. We've coined this high steel. So on the left, the Missouri University of Science and Technology project is combining a hydrogen direct reduction furnace for iron making with electric melting for steel making, and all of that's then integrated with this flexible grid. On the right side is the University of California, Irvine is heading up this project. It's also looking at using hydrogen for direct reduction, but this project is a little more focused in on the thermal and process integration of the solid oxide electrolyzer that they're going to get, I believe, from Fuel Cell Energy that's going to be combined with a DRI furnace. So both of these projects will be initially focused on demonstrating like roughly 1 ton per week of iron. And then from there, really understanding what the economic viability is with an eye towards much larger scale. These projects are very new, just getting underway, so they're only presenting posters this year, but expecting big projects or big things out of these projects next year as we look to try to decarbonize some of these really hard to decarbonize areas. All right. So finally, I'm going to switch now to our enabling activities, including manufacturing and safety codes and standards. So I'm going to start here just kind of noting that, and Ned touched on this a little bit as well, we actually have several MEA manufacturing projects slated to present on Thursday. And so I'm not going to have time today to cover all of those, but I do want to emphasize that we are focused in on developing low-cost manufacturing techniques, both for fuel cells and electrolyzers. So in that vein, here on the left side is a project from Mike Olsch at NREL. So Mike's team continues to really lead the pack globally in the area of inline quality control. And now he's added electrolyzers in addition to fuel cells. So his kind of big accomplishment from this year is he's dialed in QC techniques for membrane thickness imaging, including impacts from web line speed and reinforced and thick membranes. On the right side, in a very related project, so Mike helped put this international meeting together along with Michael Hahn from my team. So this is a joint meeting hosted by DOE and NREL. It was a 2-day international workshop on MEA QC for both electrolyzers and fuel cells. This is part of an ongoing international collaboration with NRC Canada and Fraunhofer ISE in Germany. Again, I think the key here, this year, this international workshop, it's been going on for a while, but they added electrolyzers specifically, an entire day spent on electrolyzers this year, which is really great. And I think the outcomes of this are interesting. On the fuel cell side, the QC has gotten really good. They've really, developed this techniques well. They can really see any sort of blemishes, any sort of defects. So now the problem is like, well, what really is a defect? What defects is going to create a short or going to create a problem with degradation? And then what defect is just simply a blemish in the material and it won't cause any problems down the line. So that's kind of where the fuel cell side stands. On the flip side, on the electrolyzer, the QC development space hasn't been developed nearly as much. So I think the electrolyzer industry there expressed a need to review failure modes to inform the QC development folks. Again, there's a lot going on in the manufacturing space. I don't have time to cover it. We're working on light duty electrolyzers, or sorry, low temperature electrolyzers, high temperature electrolyzers. We're working closely with Demetrius's team on the Million Mile Truck Consortium. We're looking at standardizing balance of plant, supply chain issues, lots of work in this space. All right, so now shifting on to safety codes and standards. So really here, we're pivoting beyond our focus beyond light duty vehicles. So I've challenged Laura and her team and all the folks at the labs working in this space to become proactive and get out in front of some of this, these various codes and standards issues that we envision are going to come up in the H2 at scale realm as we start to look at these really big applications. So I think an important first step here was the release of this U.S. federal regulatory map. And again, Sunita stole my thunder here a little bit, but this was just recently published. And I think this report essentially identifies all the various codes and regulations along with their government bodies that we must interact closely as hydrogen starts to enter into these brand new use spaces. So we have a really strong kind of collaboration with a few of these administrations, like Department of Defense, or sorry, Department of Transportation. But for many of these, we haven't worked with them in the past, and we're going to need to educate them on the benefits and safe handling of hydrogen. All right, so continuing on with the theme of safety codes and standards, as always, we've been funding a lot of work on the R&D space here to inform various codes and to help reduce unnecessary regulations. So there's a couple of really nice examples. There's a lot more, but I picked a couple that I thought really show a nice outcome. Both of them are from Sandia National Laboratories. On the left, Sandia was able to conduct experiments showing that fatigue crack growth rates are actually not linear, has been previously suspected, and has been assumed in the ASME code case. So based on experimental data, the lifetime of type 1 and type 2 tanks has been increased by up to 3x. So you can see this here, that the dashed line is kind of the previous extrapolated kind of assumption, and nobody had really taken a lot of data down in this lower space. Well, the group at Sandia did take a lot of data, and they actually found that there's a nice knee in the curve. And because of this knee in the curve, you can see this delta actually results in a lot longer lifetime for some of these type 1 and type 2 tanks, which really helps reduce the cost of stations and different kind of offboard storage needs. Shifting over here on the right side, again, this is a Sandia project that used Raman and lasers to examine hydrogen that is vented from liquid hydrogen storage vessels. So there's some worry here that this dense cryogenic hydrogen could sink and actually get sucked into building intakes, such as like HVAC intakes. And hence, there was some pretty significant setback distances and station footprint requirements. So fortunately, Sandia was able to determine experimentally that the hydrogen actually matched up well with the visible plume, and it goes up in the air as we had hoped. And they also looked at humidity and very minimal impacts there. So hopefully we can now use this R&D data to go back and revisit the NFPA2 liquid hydrogen exposure distances, and hopefully that'll result in reduced setback distance requirements and reduced station footprints. All right, so for my last couple of slides here, I wanted to highlight a few examples of collaboration and leveraging of funding for both domestic and internationally. On the left, upper left here, we are working closely with the FCHJU with respect to both liquid hydrogen R&D as well as protocols for heavy duty fueling. And we actually just kicked off a new CRADA project that's going to be led by NREL that'll work with and inform the PRI group in Europe. So I believe that's under negotiations right now. Moving over here to the upper right, we obviously continue to be heavily involved in the International Partnership for Hydrogen and Fuel Cells in the Economy. So we're actually co-chairing 2 working groups here, the Education and Outreach, as well as the Regulation Code Standards and Safety Working Group, all kind of aiming to harmonize codes and standards, information sharing on safety, policies, regulations, analysis, and education. Going to our bottom left here, This is the Center for Hydrogen Safety in partnership with the AICHE. It's a global nonprofit dedicated to promoting hydrogen safety and best practices. So this group is now over 60 members and growing rapidly. And finally, on the bottom right, this is another fun one to talk about. Pete's been heading this up, and we are heavily involved with mission innovation. There are a couple different mission innovation groups that Sunita mentioned, but this is specifically on the shipping one or kind of related to maritime. So this is a joint collaboration with several countries, including Denmark and Norway, focused on the entire value chain of maritime. And hopefully we'll be able to actually have some R&D results coming out of efforts like this next year. All right, continuing the theme, I think it's pretty safe to say here that we are well coordinated with collaborations across industry, states, governments, internationally, domestically, you name it. We're out there talking to folks and we're collaborating. We're trying to get the most kind of bang out of our funding. A couple things here I will highlight. So we have the interagency working group. There's approximately 15 government agencies that are well coordinated. This is a thing that monthly call that Pete leads, and it has led to a couple of specific projects. Also here over on the left side, industry engagement. A lot of folks are pretty familiar with US Drive, at least on the light duty side. We've been working on the US Drive space for a long time. Something brand new now though is the 21st Century Truck Partnership. We actually created a hydrogen and fuel cell working group. As part of that, I'm co-chairing it along with Matt Thorington from Bosch. And so here, similar to US Drive, except it's all focused on medium and heavy duty trucks. We're just up and underway. We've only had a handful of meetings, but if there's any of the industry folks that are related to kind of medium and heavy duty trucks and are interested in this and want to become part of this team, let me know. We've had a lot of interest, and we've already had some folks request to become associate members of this group. All right, so I think I'm running a little low on time. This is, you know, as Ned and Demetrius showed, this slide is nice. It highlights a lot of, you know, highlights that have come out of the technology acceleration space over the years and things that we're planning into the future. I think it looks a little denser as we move on, as the administration kind of pushes us more towards demonstrations. So hopefully that'll continue to be a theme going forward. And I'll just say it was pretty fun putting this slide together to really show all the different outcomes of our work. And it was, you know, a lot of these things didn't make the cut list, a lot of things to choose from, but really kudos to the team and to industry on all the great things that we've accomplished. Finally, I did want to reiterate, Sunita mentioned this earlier, but hot off the press, just announced today that we have released the 2021 Hydrogen at Scale CRADA call. So big thanks here to Brian Hunter, Laura Hill, and Karen Harding on my side, along with Keith Whipke and Sarah Havoc on the NREL side. So this CRADA call involves 3 different topics. The topic 1 we named H2 at Ares. And as I mentioned earlier, NREL and DOE have invested significantly to develop a platform to work with industry at the Ares facility and test and try out new integrated hydrogen energy systems. So that's topic 1. Industry could come in and, you know, partner and try out some new cutting edge grid integration type research there. Topic 2 is focused in on applied risk assessment and modeling. So again, this topic is focused on the necessary codes and standards work that'll be needed beyond light duty vehicles, as that's the key focus now going forward with safety codes and standards. And then finally, topic 3 is the development of next generation sensor technologies, specifically wide area sensors. So this CRADA call, $12 million over 3 years, up to 14 projects. Laboratories lead, but they must come in with partners from industry. So this is really kind of shows, you know, things that industry is interested in looking at and ensuring that we're well coordinated there. Proposals are due July 19th. This is the 3rd iteration of CRADA calls, and we've had some really good projects come in through this vehicle. So looking forward to what comes out of this latest effort. So finally, just about out of time here. I just want to say a huge thanks to the team. They've been very inviting and welcoming as I've come into this new role. So Michael Hahn, Brian Hunter, Pete Devlin, Laura Hill on the federal side. Zach Ty, we brought him as a new fellow to the team, so he's a recent addition. And of course, Dan Bertoletti and Karen Harding, they make my life sane and make this whole thing go around. Similar to Demetrius and Ned, I'll put a plug in. We are also looking for more help. We actually have 2 open federal positions as well as 2 fellow positions open. So if anybody's interested and you guys want to help us take hydrogen to the next level and meet the president's ambitious targets, please contact me. We are looking for talent on the team. So with that, big thanks to the team and thanks for everybody's attention.